The unknown is represented with the variable x. This time, we have x on both sides of the equation. We have here the equation 3x minus 5 equal to x. Again, it's 3x minus 5 equal to x. We are going to solve for the value of unknown, applying necessary operations and properties. But this time, we are going to isolate the variable x on one side of the equation. That would mean if we're going to pick or choose the left-hand side, we need to remove this x here. We can do that by subtracting x here, such that x minus x, by subtracting or properly subtracting terms, we will get here 0. Hence, this side will no longer contain x. But we should also do the same thing here on this side to retain equality. Hence, 3x minus x is 2x. We still have minus 5 equal to, again, this is 0. In the previous videos where we only have one unknown, or one version of the unknown, unlike this one we have two on both sides of the equation, we were able to remove this term minus 5 first, but we could also start it with this before we remove x here, but I believe this is easier for us to follow. Again, we are going to remove now the term minus 5, so it's negative 5. Take note that the operation before it becomes its sign. We are going to add here 5, such that minus 5 or negative 5 plus 5 becomes 0. Do the same thing on the other side. Hence, we'll have here 2x is equal to 0 plus 5, which is 5. To complete this process, we need to divide both sides by 2, so this would become x, and by observing the properties of equality, we'll get here a result of x being equal to 5 halves. Now you can write this as 2 and 1/2. You could also write this as 2.5, but I would like to suggest, if you have improper fractions, stay as improper fractions, because it would be easier for us to apply checking and other operations related herein. In checking, as mentioned, we are going to make sure that the equation will stand as it is if we are going to substitute our value of the unknown being 5 halves on our original equation. Our goal here is to make sure that both sides of the equation will have the same value. But since our unknown has a fractional value, you really need to remember the correct operations involving fractions. And here comes the step. 3 times x, which is 5 halves, minus 5 equal to the value of x, which is 5 halves. Okay? Take note that if this is expressed in mixed fraction or even in decimal notation, well, for some of us it is okay, but generally this is difficult to be applied, especially if we deal with multiple operations. So stay in proper fractions as it is. We are checking, so please place here question mark. Now we are going to observe the necessary operations involving fractions. Of course, this is 3/1 because an integer can be written as a fraction of over 1. So multiplying numerator to numerator, that's 15 halves minus 5, still question mark. We have here 5 halves as well. This 5 here, when written with denominator 2, is actually 10 halves. So we have here 15, or you could have LCD here of 2. So 2 divided by 2 is 1 times 15, that's 15. 2 divided by 1 is 2 times 5, so you have here 10. Hence, 10 halves. Operation, subtraction here. Okay, so you need to review your operations on fractions. Now, even if this is already too obvious, the goal of the checking is to make sure that both sides of the equation will have the same value. Hence, 15 minus 10 is 5 over 2. And we have here 5 over 2 as well. We have reached a point where both sides of the equation has the same value. Hence, This value of the unknown, being a fractional form 5/2, is the correct answer for this given equation. Join us to the next adventure involving the unknown.